The superiority of the nation's defense depends on the knowledge, skills, and behaviors of people involved in program acquisition, both government and industry. In government, the senior executive service personnel capability is the point of the spear. Yet it is being blunted and hollowed out through an increasing incidence of retirements. Replacements need to possess knowledge in STEM, especially engineering and mathematics, as well as liberal arts, including language, culture, and history, along with a new way of thinking to cope with the continual challenges of creative disruption. Not everyone can know everything in the complex world of technology, so government needs to master what is needed and where it can be found in the global technological ecosystem. And industry needs to be expert in how it is provided and how to incorporate it in the defense supply chain at zero marginal cost. Both industry and government personnel need to possess superior skills and behaviors in collaboration and team innovation management. Just how did the defense industrial base morph into a globalized industrial base, and what are its implications? From the shipbuilding arsenals of World War II to a commercialized defense with the likes of IBM and General Electric, and from there to defense specialists like Lockheed Martin, this clash of creative disruption with hard-to-change government and military cultures now calls for a fundamental shift if the nation is to maintain military superiority and not just accept a level playing field. In this new model, defense needs to be the importer of technology, unlike earlier when DoD did the exporting with technologies like the Internet and the Global Positioning System. There are numerous trends, disruptive effects, and consequences associated with the defense transition from the 20th to the 21st century, some more important than others. Genuine drivers and game changers are most consequential, such as digitization, robotics, 3D, manufacturing, diffusion, communication, resistant bureaucracy, hollowing out, political interests, and willful failure to adapt. Some factors take the form of rationalized explanations, perhaps even excuses, such as dual use, low cost of entry, export controls, spending limits, regulation, intellectual property protection, and business certainty. Other factors make an appearance as simply intellectually complete entries, such as income shares, moral constraints, public relation concerns, neglect and improvement, and reluctance to ensure competitiveness. The changing technology and its ease of diffusion are high-impact driving factors. Neither is under control by government or industry. Both are driven by competitiveness and unpredictable market forces, where any prospect for control is low. The state of an unchanging government bureaucracy and the entrenched politics are consequences of a willful failure to adapt, where the remedy is to renovate the people and their behavior, re-envision the future and alter the strategic course, and make the necessary commitment to a willful decision to adapt. Just what constructive actions are possible in the current state of affairs? Taken all together, the tenets of a strategic framework for creative disruption going forward might include the following. Adopt a strategic framework for creative disruption. Focus on software as the central element of innovation. Renovate the government senior executive service, systems and software program acquisition capability. Renovate the defense industrial base integration engineering capability. Restructure the roles of government and defense industry partners with respect to commercial technology, acquisition, the domain-specific application of emerging commercial technology, and the high-risk, high-reward upstream science-based technology exploitation more typical of the Jasons in years past. The following issues need to be explicitly placed on the government plate and periodically reviewed: adaptive bureaucracy, reform, regulatory, that is, export control and intellectual property, hollowing out, R&D spending, austerity, and industry uncertainty. The following issues need to be explicitly placed on defense industry's plate and periodically reviewed: competitiveness issues, innovation investment, income shares, short innovation, rapid diffusion, commercial public relations, and fixed price contracting. How does this macro view and fundamental shift become operationalized? The answer here, of course, lies in the investment in the knowledge, skills, and behaviors of people, including STEM, liberal arts, and collaboration. For government, this investment must begin with the renovation of its senior executive service, personnel capability, with the focus on what gets done taking precedence over how things get done. For industry, the defense industrial base needs to raise its investment levels in integration engineering and the transformation of data and information to the knowledge and insight that feed innovation and guide the demand and selection of the technologies from anywhere in the globalized industrial base that underlie the next big thing, and how to sequence their arrival in the defense supply chain and pipeline, where capabilities are coupled and mashed up, interfaced and integrated, tested and experimented with, and operationalized and deployed as a continuing stream of product components and capability increments and solutions. The result is a smart and trusted systems and software supply chain. This fundamental shift, driven by the macro and operational views and new strategic thinking described, requires not just cooperative and skillful collaboration among government and industry acquisition personnel, but also the harmonization of the disciplines of systems engineering and software engineering that underlie the systems and software program acquisition, and a way of thinking to serve as a bridge between systems engineering and software engineering. In this bridge, there are producers and consumers, organized around form, fit, and function. Systems engineers take prime responsibility for function, including the opportunity value proposition, application domain knowledge, requirements, specifications, and system architecture. Acting as consumers of the systems engineering work products, software engineers take prime responsibility for form and fit, including software system architecture composed of nodes and arcs, computer resource loading and scheduling analysis, and iterative design and incremental release strategies. As systems engineers and software engineers interact and mutually refine these form, fit, and function work products, the result is an integration engineered value-added systems product. The increasing incidence of retirement and the growing disconnect between DoD needs and the industrial-based capabilities is hollowing out the senior executive service personnel capability. Cross-discipline collaboration and the senior executive service retirement bubble invite an initiative to renovate the senior executive service capability associated with systems and software acquisition. As the long-awaited bridge between managers and software engineers, the overarching framework of the CMAT essence kernel encompasses a useful and strategic way of thinking, whose adoption would extend the capability range of senior executive service personnel needed to place them on an even playing field with the systems engineering and software engineering technical practitioners they depend on. This evolving standard of excellence characterizes the maturing of the software profession and stands on the shoulders of those who came before, yet reflects an understanding of the plight of the professional software engineers and programmers who toil in the vineyards today against mounting complexity and insufficient education. Such positioning can go a long way in bridging the generation gap, a growing influence in today's way of working. Here is my contact information. I would be happy to receive questions and have discussions with people on this important subject.